All right, everybody. So I wanted to talk about a really big idea, which is the idea of an inverse and how sometimes when you take an inverse, you get something that is a function. And sometimes when you take an inverse, you get things that are not a function. And so I'm going to do this in two different videos. In this first one, I'm going to look at a more simplified example. And then in the second one, we'll look at a little bit more of a complicated example where there's a little bit more business going on. So for the first one, what I'm going to do is I'll write out an equation that's got a couple things going on. We'll do negative 3x plus 5. So you should be able to visualize, more or less what that's going to look like if I tried to graph it. If I tried to graph it, it would start at y equals 5. It would go down 3, right 1, down 3, right 1 because of the slope. What I'm going to do is I'm going to show a couple of points, how you get those points by hand, then remind you what the graph shows you, and talk about what the inverse does. So, for example, the equation is kind of like a recipe for what I should do with an x value. So, let's say I'm curious for some reason about the x value of 2. The equation tells me that the y value is negative 3 times 2. That is my first step. And then plus 5 is my second step. And so I end up with a y value of negative 6. I did that part first. Plus 5. I do that part second. I get negative 1. And what that means is in a minute here, when I click graph, I'm going to get a point right here at 2 comma negative 1. Now the equation is in the form y equals blah, 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 which means it tells you the steps in order if you start with x to get a y value. Now what about the opposite question? What if I asked you for y equals 11? I guess 11 will be off my graph. So I'm going to choose a different y value. See, we all make mistakes. What if I did y equals 3 for whatever reason? That's going to be on my graph. Well, in this case, it's a little trickier. I can still use my equation, 3 equals negative 3x plus 5. But what do I have to do is I have to undo. That's the idea of an inverse, is it undoes a function. I have to undo the previous function. And I want you to pay attention to how I undo it. I subtract 5 first. So I get negative 8, or no, sorry, negative 2 is negative 3x. And then what am I going to do second? I'm going to divide by negative 3. So we end up with 2/3 equals x. So let's see, 2/3 is going to be about here, and that's at a y value of 3, so we're going to be right about here, 2/3 comma 3. So what I want you to notice about the inverse is it does the opposite operations in the opposite order. I'm going to say that, I'm going to write that, you should write that. An inverse does opposite operations in the opposite order. What does that mean? If the original function says times, the inverse will divide. If the original function says plus, the inverse will subtract. And if the original function has an order of first and second, that order is going to be flipped for the inverse. This is a really common thing. An example I use a lot with students is in the morning, you put your socks on, you put your shoes on, you tie your shoelaces. If you try to mix up that order, it's not going to go so well. In the evening, you untie your shoelaces, you take off your shoes, you take off your socks. So each of the three operations in the morning, socks, shoes, laces, was undone in the opposite order when you got done. So let's look at this. I'm going to type in y equals negative 3x plus 5. It's going to hit through the two dots, more or less with where I graphed the 2/3. I guess I was a little bit too far to the right. And then what I'm going to talk about is the inverse function. So notice what the inverse function is. I go like this. X minus 5. Why did I put it in parentheses? Because I want it to be clear that I'm doing that part first. And then I divide by negative 3. Now you may not notice much important about that function yet, but what I can guarantee to you, based on the work we've done so far, is I know 2 points that are on that function. And those 2 points are the inverses of the 2 points that I found. Remember, there was nothing really particularly important about these 2 points I found. I just chose a random x value and a random y value. The idea that I'm trying to show you is that in general, any x comma y on the function, any point on the function will have its inverse point on the inverse function. So I guarantee you that as I type in here 3 comma 2/3, it's on the inverse. And check it out, that green point landed directly on the inverse. I guarantee you as well that as I type in negative 1 comma 2, that will also land on the inverse. This is always true. Just to show one other thing, I want you to think about how are these two lines related to each other. They don't look completely random. They have some sort of symmetry going on here. There's 2 different possible lines of symmetry. One of them is true for every inverse function, and that is the most simple line that there is, y equals x. I want you to think about why the line y equals x is a line of symmetry. One reason why is because the inverse takes one y value and makes it equal the other x value. The switching I just talked about, where, for example, the 2 became a negative 1 and the negative 1 became a 2, that is literally reflecting the y value to equal the x value. And that's why the middle line, the line of symmetry, is y equals x. One last little connection, because we talked a lot about perpendicular bisectors last time. When you have a line of reflection, that line of reflection is a perpendicular bisector connecting your original point, A, to its inverse point, A prime. That's kind of neat. So if I go between B and its image, B prime, the line of symmetry is a perpendicular bisector. So there you go. Let me know if you have any questions or comments. We'll keep working on inverses. I'll make another video in a second with a more complicated function.